Hi everyone, this video is an exercise 11, the question 6. So in part A, we want to use the fact that cot x is equal to cos x over sine x to integrate cot x dx. So as the question shows, or actually this is something that we need to know in general, cot x is equal to cos x over sine x dx. And in order to integrate this, once again, whenever you see a fraction, the first thing that you should think of is the reverse chain rule. And the biggest indicator of that is when the numerator looks like the derivative of the denominator. So in this case, actually, it is the case because um, the derivative of sine x is cos x. Now, the first guess here is that when the power of the denominator is 1, we actually go with len. So in this case, our guess is len sine x is basically the answer. Now let's differentiate this and see if it's actually the answer. So if you differentiate, first you write sine x on the denominator, and then on the numerator, you just differentiate sine x, which is cos x, and that's exactly the correct guess. So therefore, the answer is just len sine x plus c. So that's the answer here. Now for part B, we want to integrate tan dx, and we want to show that that's basically equivalent to len sec x plus c. All right, so this is the same approach because tan is equal to sine x over cos x. And once again, we can use the fact that in terms of the educated guess that len cos x is the answer, because the derivative of cos x is minus sine x. So as you can see, I know that on top we have just sine x, but that's fine in this case because we can adjust that later. So when we have len cos x and we differentiate that, we'll have minus sine x on numerator, and denominator is cos x. But here is sine x over cos x. So in order to basically cancel out this negative sine x, we must have negative 1. So therefore, the answer is negative len cos x. And that's basically the derivative. But remember that the question says show that this is equivalent to len sec x. But this is something that is very easy because we know that sec in general is 1 over cos x. So we need to find a way such that we get 1 over cos x on the, inside the modulus rather than having, or actually inside len rather than cos x. So the key here is this negative, because if we do len of cos x to the power of minus 1 plus c, then that essentially, this is just a property of logs in general. So that is equal to len of 1 over cos x. And this is the same as len of sec x plus c. And that's exactly what we wanted to show here.